This is a simple electric circuit. We have a light bulb connected to a battery here, and we have a measuring instruments. This is an ammeter. It measures the electric current in the circuit. This is a voltmeter. It measures the voltage difference across the light bulb. It is easier to deal with symbols rather than to draw the whole thing. So this is the symbol for a battery. The long dash represents the positive electrode, the electrode that has higher potential. And the short dash represents the electrode that has the less potential. There is a potential difference between these two electrodes. For simple batteries, this is 1.5 volt. This is another 1.5 volt. When you add them in series, you get 3 volts for this circuit. This is the symbol that we use for light bulb. This is the symbol that we use for ammeters, the current measuring devices. And this is the symbol that we use for voltmeters, the voltage difference measuring devices. As you can see in this circuit, a meter usually is connected in series. A meter is connected in series. That is to say, all the current that passes through the light bulb will pass through the ammeter as it continues to the other electrode of the battery. On the other hand, voltmeters are connected in parallel. Voltmeters are connected in parallel with the part of the circuit that we are interested in measuring the voltage difference. So you are talking about voltage difference across the light bulb. That is to say, between the two ends of the light bulb. And you are talking about the current going through the light bulb. Okay. In electric circuits, usually we use multimeters. A multimeter is a device that can be used to measure voltage difference, to measure current through, electric current through, to measure resistance, to measure all kinds of quantities, physical quantities that we need in electric circuits. Usually, we have different ranges here that we use this knob to set the proper range. As we measure electric quantities in circuits, usually we start with the higher range and go gradually to the next smaller range in order to improve the sensitivity of the multimeter as we do the measurements. Like if you are measuring current, usually it's good to start assuming it is the highest current, 10 ampere, and then if this scale seems to be not the proper scale, we go down to smaller values. So here you have 10 ampere, then if this scale is not right, we move the knob to the next scale. The same can be said for voltage. You start, for example, with 1000 volt. If this seems to be high, you move down to other scales such that the sensitivity is the best when you do the measurements. Look at the 4 circuits shown here and select those that will light the bulb. To answer this question, you need to make sure that you have a closed and complete circuit. So if you check this one, both ends of the light bulb are connected to the same lead, nothing connected to the negative lead. So this is not a complete circuit. This light bulb will not be on. If you consider this one, you see the 2 leads of the battery are connected to the same point here. And we don't have a complete circuit. So this also will not function. If you consider this one, you see the positive lead connected to the first lead of the light bulb, and then the second lead is connected to the second lead of the Battery, yes, this is a complete circuit, so light will go on here. Here also we see the same circuit, but now we inserted an ammeter in series in order to measure the electric current through the light bulb. So this one also will be on.